بسم الله الرحمن الرحيم، السلام عليكم ورحمة الله وبركاته. فريق أرشفة يرحب بكم اليوم في برنامج الثالث لهالترم هو معسكر أرشفة. هلب سيشن اليوم لمادة فيزيكس 101 يقدم الدكتور مراد حمد يعطيه العافية. الهلب سيشن بيكون مسجل، تلقونه بقناة أرشفة باليوتيوب، أرشفة KFUPM. فيها محتوى أرشفة المعتاد. وأيضا المزيد عن أخبار أرشفة تابع حسابنا في تويتر أرشفة KFUPM، تلقونه تحت البوستر. الله يهينكم، عدد طلاب واجد، اللي بيسأل يرفع يده والدكتور ما راح يقصر معه وبس. والله يعطيكم العافية، نزلكم مع الدكتور. شكرا دكتور.
شكرا لك، يعطيك الف عافية. السلام عليكم everybody, and today we will review.
السلام عليكم. السلام دكتور.
السلام، حياكم الله. We will review last few chapters for the final exam. In fact, this will not be the only review. There will be another review arranged by معسكرأرشفة. جزاهم الله خير. I think it is on Sunday on the same time. We'll review the whole chapters, inshallah. Okay, let me start this session. Again, I will review chapters 12 to 15, and here there is a attendance link. You will find this link after every 3 or 4 questions. So kindly, before you leave, do the attendance just to help us to improve this session and to help you. Okay, in this session, I will start solving questions from chapter 15 and go back to 14, 13, and 12. For example, I will start from this question. Here in the first question, we have a physical pendulum consists of a uniform meter stick. Wherever you see uniform meter stick, which means we have length, the length is equal to 1 meter. And since it is uniform, so the mass everywhere in this stick is uniform. And this stick is pivoted at the 40 centimeter mark of the meter, which means if you have a meter stick, for example, that has length of 1 meter, in the center here at 50 centimeter, we have center of mass of this stick, and it is pivoted here at 40, here 40 centimeter, and this one is 50 centimeter. Since from here to here is 40 centimeter, so this will be 10 centimeters. Okay, Shabab, clear? Okay, the center of mass of the stick is located at 50 centimeter. Find the period of oscillation of the pendulum. We know from chapter 15 that the period is equal to pi square root I over mgh, where I is, do you remember what is I, Shabab?
I com
plus mh squared.
Okay, here I is the rotational inertia, and I for the stick usually is equal to, if it is pivoted, for example, from the center, it is m L squared over 12. This will be given in the formula sheet. However, here it is pivoted at place other than the center. If you remember, we will use the parallel axis theorem. So I will be I center of mass. So this is I center of mass, and plus mh squared, where m is the mass of the meter stick and h is the distance between the center of mass, which means this point, and the pivoted point. And we can substitute it in this equation directly. So the period is equal to pi square root of ml squared over 12 plus mh squared divided by mgh. Here we need some mathematics. If you take m as a common factor, here you can eliminate m with the 1 in the denominator. So we can eliminate this one and this one with this one. And we know that L is equal to 1 meter, H is equal to 10 centimeter, which means 0.1 meter, and we have G. So only just substitute these amounts. So we have 2 by square root 1 squared, which is 1 over 12 plus 0.1 squared divided by 9.8 times 0.1. And if you calculate this one quickly, you can find the answer is about 1.94 seconds. Kindly, if anyone has a calculator, check with me during the this session. Okay, Shabab, the answers. Now, since we have this answer, we need to find it in the answers or in the choices. We can find it here, so our answer is correct. Another question, Shabab. Here we have a 0.25 kilogram mass oscillates on the end of the spring with a spring constant. So this is the mass, and this is spring constant is equal to 100 Newton per meter. If the system has energy, which is E, equals 6 joule, find the maximum speed of the block. In such questions, usually, since we have E and we need speed, we need to remember that E is equal to half kxm squared, and we remember that the maximum speed Vm is equal to omega xm, and omega, if you remember, is equal to square root of spring constant divided by the mass. So this what we have. So how can we find this velocity? Simply, we can say Vm is equal to, instead of omega, since I have k and I have m, it's equal to square root k over m. Now it is multiplied by xm, but I will, from this equation, say that xm is equal to 2e divided by k under square root. Am I right? So instead of xm, we need just to multiply by this amount, 2e over k. Since we have a product here, we can merge them in one square root. So we can eliminate k with k, and we will end up with, the answer is 2e over m. Substitute our values. We have 2 and E is 6 joules divided by the mass 0.25. And if you calculate this one, the answer will be given something like 6.9 meter per second, which is the correct answer. Clear, Shabab?
All clear.
Okay, Shabab. Now, one more question. We have here the displacement of an object oscillating on spring is given by this equation. X of t is equal to xm cosine omega t plus phi. Now, if at t equals 0, which means just substitute 0 here, the displacement is 0. So this one becomes 0. And the velocity is in the negative direction. Okay? Then what is the phase constant phi? Okay. It is mentioned in the question that x of t equal to 0 when t equal to 0. So we will end up by 0 is equal to xm cosine phi. So actually it was x of t is equal xm cosine omega t plus 5. Now instead of t, I will put 0. So we will ignore this term. We will end up by x cosine phi, and it is equal to 0. So from this equation, we know that cosine phi is equal to 0, but just divide by xm, and phi will be equal to cosine inverse 0. If phi is equal to cosine inverse 0, so phi will equal to pi over 2, if you can use it by calculator, 3 pi over 2, 5 pi over 2, and etc. So let us compare our choices. Here we have pi over 2, and we have 3 pi over 2. So how can we decide that is A or C is the correct answer?
Because of the direction of the speed.
Excellent. We have a keyword that the velocity is in the negative x direction. We know that velocity of t is equal to minus omega xm sine omega t plus phi. Now, at t equal to 0, v of 0, so this term will be 0. So it is equal minus omega xm sine phi. And it's given that this is in the negative direction, which means this is lower than 0 or less than 0. Now, by comparing this equation, sine phi should be greater than 0, because here we have minus, omega is positive, xm positive, and this one will be positive. So when sine theta is greater than 0, that means phi is equal to pi over 2, if you calculate it using the calculator. Clear, يا شباب?
Yes.
Okay, because sine 3 pi over 2, which is 270 degree on calculator, it will give you minus. Okay يا شباب؟
وش القانون المستعمل يا دكتور؟
لا، ايش القانون؟
حق الاكس تي equal mx cosine v.
Okay. This is the first equation given in this chapter, that x of t, which means the displacement, is equal to maximum amplitude times cosine omega t plus phi. We always start from this equation. Now, if you derive this one, first derivative, if you remember from chapter 2, the first derivative of the displacement will give you the velocity.
اي نعم صحيح.
Okay, so if you derive this one, you will get this equation of the velocity. Clear?
كلير. مين موجودة في الفورمولا شيت صحيح؟
I don't know, but it's easy. You don't have to have it in formula sheet.
موجودة في الفورمولا شيت.
Okay, I think the first one is given, يعني information, but the second one, it's not necessary to be given. You can just derive it.
صحيح.
Okay. Now another question for the other chapters. Here we have in this figure, we have water flowing through a horizontal tube. First of all, horizontal tube, which means both sides have the same elevation, يا شباب. Okay. Now, this tube has a variable cross sections with A, which means the area, A1, this one, is equal to 30 centimeter squared, and A2 is 20 centimeter squared. This is A2. Now, the pressure difference between the two sections, which means pressure 1 minus pressure 2, is equal 150 Pascal. This is given. Find the water speed at the wider section, which means V here, V1. And here, this is V2. Okay, Shabab? Clear what is requested from this question?
So horizontal tube means what?
Sorry?
Can you again say it again? You said horizontal tube means something.
I will explain it now. Okay. Now
Just
here
horizontal tube.
it's given the pressure difference is equal to this amount. We have the area here, horizontal, which means the elevation y or h here is equal to h here. Okay, شباب? Horizontal, which means y1 is equal to y2. Now, if you remember Bernoulli equation, we said that P1 plus half rho V1 squared plus rho G H1 or Y1 is equal to B2 plus half rho V2 squared plus rho G H2. Now, it said that B1 minus B2 is equal to this amount. So I will just transfer this one here and the rest in the other direction. So we will end up B1 minus B2 will equal to half rho V2 squared minus half rho V1 squared plus rho GH2 minus rho GH1. But H1 is equal to H2 since it is horizontal. Okay? Is it clear, Lisan? So this minus this one will give 0. تمام. طيب. Now he looks for the speed at the wider section, which means V1. V1 minus P2 is given, rho is given, V2 is unknown, rho is given, V1 is unknown. So we have one equation with two unknowns. But if you remember the continuity equation, we know that V1 A1 is equal to V2 A2. So V2 will equal to A1 divided by A2 multiplied by V1. Is that correct?
Yes.
So instead of V2, I will substitute this amount. So B1 minus B2 equal half rho A1 over A2 V1 squared minus half rho V1 squared. I just want to rearrange the equation. So this will equal half rho. I will take V1 common factor here and half rho is common factor here. We will end up by A1 squared over A2 squared minus 1. Am I correct?
Yes.
Yes, correct.
Okay. So from this equation, so you can say delta B, no problem. From this equation, if you rearrange, so V1 will equal to B1 minus B2 divided by half rho A1 squared divided by A2 squared minus 1, all under square root. Okay, just substitute the values. So V1 will equal to B1 minus B2 is given 150 divided by half rho for water, it is 10 to the power 3 or 1000. Multiplied by A1 is given 30 centimeter squared. So it is 0.0 3 squared divided by 20 centimeter, which is A2, 0.02 squared minus 1, all under square root. If you calculate this one, this will give you, by the way, you can here substitute 3 squared directly. Okay, let me substitute, because
it's a ratio, it won't different.
Yeah, it is ratio, so they will eliminate each other. So this will be 3 squared over 2 squared. It will not affect the answer. Now, if you calculate this one, the answer will be 0.49 meter per second, which is our needed answer. Clear يا شباب this question?
Yes, please.
Okay.
Why we didn't say
let me see.
P2 minus P1 is equal to 150?
Again.
Why we didn't say that P2 minus P1 is equal to 150 Pascal in the first place?
Okay. Even if you do that, try it again. You can just transfer B1 to B2 and transfer the other here. Okay. Try it. Why not? يعني.
Okay.
It will give you the same answer, but since okay. I have never tried it, but I think it will give you the same answer. Okay.
دكتور
Okay.
مش هو المفروض ال pressure at A1 is greater than the pressure at A2?
Why?
Because at A1 the velocity is less than A2.
Okay. The pressure at A1, and okay, you can use this one. The velocity at A1 is greater than velocity at A2. So the pressure here and here. Okay. The pressure at here, it will be force over area. Okay, just try it. No problem. Okay. Just
okay.
It will have minus, and I have never tried it. Let me try it, and I can answer you after the trial. Okay.
Okay, I have another question.
Yes, please.
The elevation is at the center of the area?
Yes.
Okay,
Actually,
thank you.
since it is horizontally, it's the elevation of the flow. Okay. Okay. Here again, Shabab, we have the link for the attendance. You can do the attendance.
Doctor, I don't think they can copy it because you're sharing your screen, not the file. If you could just paste it in the chat.
Okay, you can use the barcode. Just scan this barcode.
Oh, okay.
Okay.
It doesn't work. It's lagging.
Sorry?
It doesn't work.
No, it happens. It takes a lot of time to load the page. It always happens.
Okay.
Yes, teacher, it's better even if you can send the link in the chat.
Okay, I will send it. Don't worry. Okay. Okay. One more question, ya Shabab. A water line enters a house 2 meters below the ground. Here we have the ground, and this is the water line. It is 2 meters behind the ground. A smaller diameter pipe carries water to the house floor located at height 5 meters. So here it is a smaller pipe, but it has 5 meters above the ground. If the water flows at 2 meters per second in the entrance, so velocity here is equal to 2 meters per second, and it is 7 meters per second on the roof. Here it is 7 meters per second. Find the difference in pressure between the line and the entrance. So it's the it asks for the pressure difference. Pressure difference, which is delta B, or B1 minus B2. Okay, Shabab?
We will use Bernoulli equation.
Yes. Again, here we have B1 plus, طبعا assume this one and this two. Okay, Shabab? B1 plus half rho V1 squared plus rho G H1. This should equal to B2 plus half rho V2 squared plus rho G H2. Since it asks for the difference, we can say that B1 minus B2, this will equal 1/2 rho. I will take it as a common factor. V2 squared minus V1 squared plus rho G H2 minus H1. Okay? Is it clear what I did here?
Teacher, why it's not B2 minus B1?
Okay, it's for the same reason. Try it. Try it. Just try it.
It will be the same.
Just take. You need to the magnitude. Okay.
Yes, I need the mark. Okay.
Okay. I will find the better answer and answer you. Okay.
Doctor,
Yes.
7 up, we take it minus or positive?
Okay. What's important here is delta H. Either you make it this negative minus 2 meter, and this is 5 meter, or you can make this one 0, so this one will become 7. Okay. The most important here is the difference, which is delta Y or delta H. Okay.
Okay.
Let's see what we will have here. Okay. So delta B, B1 minus B2 is equal to 1/2 10 to 3. So V2 is 7 squared minus V1 is 2 squared plus rho, it is 10 to 3 times 9.8. Now, regarding to H, either you say that it is 5 minus 2, which is 7, or take the difference directly. Assume this one is 0, so from here to here 2 to here is 7. Okay, Shabab? If you take this 0, this one will be 7. Okay, or use this directly. 5 minus 2, it will become 5 plus 2, which is 7. Okay, Shabab? Just calculate the magnitude here. It will give you 9,110 Pascal. Okay, but here the answer times to 10 to power 4. So just move 1, 2, 3, 4. So the answer is equal 9.11 10 to 4 Pascal. Clear, Shabab?
Yes, clear.
Clear.
Okay. One more question. A piece of aluminum of 27 kilogram mass. So this is the mass. And the density rho of aluminum is 2,700 kilogram per cubic meter. Suspended from a string, is completely immersed in a container filled with water. Which means I have a container filled with water. Here we have a piece of aluminum suspended by a string. Now, the density of water, this is rho of water, is 1,000 kilogram per cubic meter. Determine the tension in the string after the aluminum piece is immersed in water. Okay, according to Newton's second law, we know that F net is equal to mass times A, acceleration, صحيح? Or what is the net forces acting on this aluminum piece? We can say here we have the weight, mg, or force due to the gravity. Here we have the tension force, and we have the buoyant force upward. صحيح شباب? So here we have tension plus buoyant force will equal mg. طبعا since it is not moving, this will equal to 0 because the acceleration is 0. Okay, so tension plus Fp minus mg is equal to 0, or tension up, buoyant force up, mg down. You can write it in either way. Okay, so the tension equal to mg minus buoyant force. But if you remember, the buoyant force is equal to mass of the fluid, which is the water, times g, and equal to rho of the fluid, volume, times g. And we know that the volume of the displaced fluid or displaced water is equal to the volume of the immersed object. So this is equal to volume of the aluminum. And we know that the volume is equal to mass of aluminum divided by density of aluminum. Because if you remember, we know that rho is equal m over v. So v is equal m over rho. Okay. So instead of point force, we will substitute this amount. So the tension will equal to the m of aluminum. This is for aluminum. Minus g minus rho of water, mass of aluminum divided by rho of aluminum times g. Just substitute what we have. We have mass of aluminum is 27 kilogram times 9.8 minus rho of water is 1000. Mass of aluminum is 27 divided by 2700 times 9.8. If you calculate this one, you will get exactly 166.6 Newton, which is the needed answer. Clear يا شباب?
Yes, clear.
Clear.
Okay. So let's move to another question. Here in this figure, we have a U-shaped tube open to the air at both ends. If density of water is 1 gram per cubic centimeter, then determine the density of oil filled in the left column of the tube. We need to analyze this figure. Here we have atmospheric pressure, B0, and similarly here we have atmospheric pressure since it is open. And you know, the pressure at the same elevation is equal, which means if you take this point and this point, they have the same pressure. So pressure on the oil, this point on the oil is equal to the pressure on this point in the water. Okay, Shabab? And this equal to B0 plus rho of oil, G, and H of oil. And this one is equal to B0 plus rho of water, G, H of water. طبعا if you move this one to the other direction, they will cancel each other, B0 with B0. We will end up by this term is equal to the other term. And G here will be go with G here. So rho of oil equal, if you rearrange, rho of water multiplied by H of water divided by H of oil. Now, our job is to find H for each one. Here, H of oil is equal to 12 centimeter. But how much H of the water? Any idea? Sorry?
4.
It will be 12 minus 4, which is 8. Okay, Shabab? Because to here we have 12, since it have the same elevation, and this one is 4 centimeter, so we'll end up by 8 centimeter. So the answer is equal, rho is 1. طبعا يا شباب, here the answer is needed in gram per cubic centimeter. So just make it in the same units. So rho here, not 1000, it is 1. It's 1000 when we have kilogram per cubic meter. If you convert it, you will get it 1 gram per centimeter cubic. So times 8, which is the H of water, divided by 12. If you calculate this one, you will get 0.67 gram per cubic centimeter, which is this answer. Clear, Shabab?
Yes, clear.
Okay.
الاتش اللي فوق يا دكتور. Why it's 1 multiply 8?
Which one? Yes, here. Is there any problem to here?
No. here.
Now, white one, because rho of water is equal to 1,000 kilogram per cubic meter. Okay. If you convert this one to gram per centimeter cubic, can you convert this one to this one?
Yes, it's clear
No,
now.
you
But I want to just take a look.
Okay. Okay, let's go to another chapter. This is a conceptual question. The question says, if an object is fired from a planet surface with a speed equal to the escape speed, so v is equal to v escape, which one of the following statement is correct? Okay. The mechanical energy of the object at the planet must be 0, greater than 0, less than 0, or depend on the object mass or radius mass, or object radius. It is sure that the escape speed from the planet surface does not depend on the radius, because we know that v escape is equal, if you remember, square root of 2
G
mass of Earth divided by
gm
the
over
radius of
r.
Earth. So it does not depend on the object radius, neither the mass radius. So this one we can eliminate them. Okay. It is only depend on the mass of the planet. This is not actually Earth. It is a planet in general. But okay, make it the planet. But usually we use the Earth. So it is 2 gm over r. Okay. It depends on the mass planet and the radius. Okay. Now we need to know it must be 0 or greater than 0 or less than 0. Since we are talking about mechanical energy, we can say that mechanical energy, if you remember, is equal to kinetic energy plus potential energy. And since we have a speed, we know that the kinetic energy is equal to half mv squared. And the potential energy, it is minus g mass of the planet and mass of the object divided by the radius of the planet. Okay, but here it is given that v is equal to v escape. So in fact, this one is v escape. And we know that the v escape equal to square root of 2 gm over r. So v escape squared is equal to 2 g mass of the planet divided by r. And this is u. Is it okay?
Yes.
Yes, okay.
Now we can eliminate this 2 with this 2, and rearrange this one. We end up by g mass of the planet, mass of the object divided by r minus g m small m divided by r, and this equal to
0.
0. So now we convince ourselves that A is the correct. Okay, Shabab? It might give you in the question or in the exam that speed is equal to half of the escape speed. What you can do here, just divide this by 2. And don't forget the square. Okay.
دكتور
Some.
يمديني أحلها بطريقة أخرى، إني أقول إن في النهاية يعني الميكانيكال انرجي تتساوى في جميع الهول تريب للأوبجكت، وفي النهاية راح تكون سبيد 0 والآر كبيرة مرة، إنه بتكون negligible اللي هو الجرافيتيشنال فورس.
It's your way, but أنا in this session I have to show it يعني physically. يعني I have to explain it in the physics point of view. I have to use equations just to convince you, and I can directly say that E mechanical at the surface equal to E at the infinity, and this equal to 0. But and I have to convince you, so I use this method. Okay.
اوكي.
If you have يعني another way to solve any question, just try it. Why not? يعني.
اوكي.
Okay, شباب. One more question. Here we have a 10 kilogram rock headed directly toward Earth. It has a speed of 10 kilometer per second. Look here, it is kilometer per second, not meter per second. And this might يعني, trap you in the solving this question. Now it's relative to Earth. When it is located 4 Earth radii from Earth surface, which means here we have the Earth surface, it has RE, and it's located, let's say here, and this one is 4RE. So what is the distance from the center?
5RE.
5RE. Okay. Now neglect the effect of the Earth's atmosphere on the rock. Find the rock mechanical energy just before it reaches the surface. Okay, شباب? So now it asks for the mechanical energy. So E is equal to, since I have a velocity, I can use half mv squared minus g m divided by, now it is r plus the elevation, which is 5re. طبعا remember أنا just I skip that E equal to K plus U. I assume you know it. Okay, شباب? Try to substitute. It is half. The mass is 10 times the velocity. Okay, velocity here not 10. You can say 10,000 يا شباب. Okay, شباب? And then it is squared. Otherwise, you will get the answer not correct. Minus G, I think G it is 6.67, 10 to power minus 11. Mass of Earth, it is 5.98, 10 to 24, divided by 5 times R. R, I think it is 6.37. 10 to power 6. If you calculate this one, you will get the answer is 374767347. What's that? Joule, okay. But the answer here is 3.75 10 to power 8 joule, for example. Simply, just we can convert it to this form. You can move it from here. 1, you move the decimal, okay, decimal place. 1, 2, 3, 4, 5, 6, 7, 8. So you can have 3.747, etc. 10 to power 8 joule, and which is equal almost يعني 3.75 10 to power 8 joule, which is our answer. Clear يا شباب؟
دكتور
سم.
سم الله يعدوك. يقول في السؤال find the rock's mechanical energy just before it reaches the earth surface. ليش قلت يا دكتور المسافة بينهم 5RE؟ ما هو المفروض تكون RE because just before it reaches the earth surface.
طيب وين راحت الآن الميكانيكال انرجي اللي لما انت كنت فوق؟ ما هي طالما انت تنزل الميكانيكال انرجي تقل، لكنها تعوض في الكاينتيك انرجي. try it, do it.
اوكي.
دكتور
نعم.
هل في ماس نضربه في اليو؟
سوري؟
هل المفروض نضرب ب 10 في اليو؟
I don't understand. 10 في ايش؟
اللي هو الماس ما ضربنا ولا سوينا له elimination؟
لا في 10. اوكي انا قلت لك بدايه واحد يتبع معي في هذا مرات بسرعه. اوكي you have to use all terms. okay thank you. okay يا شباب and one more question. Determine the speed of the Hubble Space Telescope orbiting at height 598 kilometers above the Earth's surface. Okay, here we have the Earth's surface, and here we have the Hubble telescope. It's orbiting, and this reminds us with Chapter 6. If you remember, we know that the centripetal force is equal to mv squared over r. Do you remember this one?
Yes.
Yeah.
You remember this one from chapter?
Yes, from chapter 6.
Yes, exactly. So if here is the force that we know from this chapter, which is equal to g mass of the Earth, mass of the telescope divided by r squared. This is equal to mv squared over r. What I want to say here that this is the radius of Earth, and this is not here, sorry. And this one is h in the red. R here is equal to h plus r Earth because we need the distance from the center. Okay, shabab? So m can be cancelled with m, r can be cancelled with the square, and we are looking for the velocity. So velocity is equal to g m Earth divided by, instead of r, I will put h plus r Earth under square root. We need to substitute the values. So g, again, it is 6.67 10 to minus 11 times the mass of Earth is 5.98 10 to 24 kilogram divided by h, it is 598,000 because it's kilometer. We need to transfer it to meter. 10 to 3 plus r of Earth, which is 6.37 10 to 6. شباب تابعوا معي بلاش انسى حاجه. And if you calculate this one, this will give you 7.566 meter per second. Again, the answer in form 10 to power 3. So just we convert it, move the decimal 3 points, 1, 2, 3. So it is 7.566. We can put it 7, 10 to power 3 meter per second. Okay, shabab? Which is
from where you get the first equation, F equal mv square over r?
Okay, this is centripetal force because it is said here the speed of the Hubble space orbiting at height. Orbiting, which means it moves. Okay.
Okay.
Here is the trick in such questions. You need to يعني انك تتذكر الشغلات اللي اخذتها جميعها وتستخدمها في الحل. Orbiting, orbiting which means moving. Still orbiting, which means moving. So we have centripetal force. Okay.
دكتور
تفضل.
الاوربتنج يعني الكي اللي نستخدم فيها السنتربل فورس، فاي اي سؤال تقريبا في الاوربتنج يمدينا نستخدم فيها السنترال فورس، صحيح؟
Yeah. Here in this question, orbiting, and he asked for velocity. Okay. And he gives you only elevation. So the only way to solve this one, and I see it is then the centripetal force. If you have another way, that's okay. Let us know.
اوكي يعطيك العافيه دكتور.
الله يعافيك. Okay. One more question, شباب. A uniform solid sphere has a mass of 1.5 10 to the power 4 kilogram and a radius of 1 meter. A particle of mass 1 kilogram is inserted and placed at a distance of 0.85 meter from the center of the sphere, which means that I have a solid sphere with radius 1 meter, and we have another particle centered here at 0.85, and this is 1 meter. Okay. Find the magnitude of the gravitational force due to the sphere on particle. Okay, here, if it is a sphere, as mentioned in chapter 13, we know that F equal to G, mass of particle, mass of the sphere, divided by radius of the sphere cubic times the position of the particle. Now, if it is shell, the answer will be 0 directly. You remember this one from chapter 13?
Yes.
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 So just we can substitute because we have solid sphere, not shell. So it is equal to, again, 6.67 10 to minus 11 times the mass is small m, which is 1 kilogram, times the mass of the sphere, 1.5, 10 to 4, divided by r is 1 cubic, and times small r, which is 0.85 meter. And this one gives you 8.5 10 to minus 7 Newton. Clear يا شباب؟
It's r cubed, not r square.
Okay. Do you remember chapter 13?
Yes.
كنا نقول في chapter 13 إنه إذا في عندك solid sphere, okay, the force here is equal to G M over R squared, or خليها capital R. But force here it will be R instead of R squared, and this H, it will become R plus H squared. صحيح؟
صحيح.
Force inside the sphere so the only affecting this sphere will be this radius. So this will become R cube R. Okay. الآن for this one, الآن لو افترضنا إنه هذا instead of 0.85 it is 1. يعني this one become here. So this one become 1 capital R. صحيح؟ Capital R with R cube to become R squared. Okay?
Okay.
Remember the concept in chapter 13.
Doctor, can you please repeat what you said
Where?
for the R cube?
Okay. Here. Now this is small r and this is capital R. If R goes to capital R, and if small r becomes capital R, so just substitute capital R here. So R will be eliminated with the cube and we will have square. So you go back to the original equation. Clear?
Yes.
Okay. Okay, Shabab, here we have two satellites, A and B, are orbiting the Earth. Okay, satellite A, لاحظ هنا we have orbiting again, but do they ask for velocity? Let's continue. Let's see. Satellite A is 4 times as far from the Earth center as satellite B, which means here is the Earth, for example. Here is the satellite A, and here is satellite B. Okay. Sorry, here's satellite B, and here A. So R from here to here, this is R B. and this one is RA. It says that RA is equal to 4RB. Find the ratio of the period of satellite A to the period satellite B. يبغى T of A divided by T of B. How much? Okay, they don't ask about the velocity, they ask about the period. Now, if you remember from this chapter, we say that T, or T in general, squared is equal to 4 pi squared over G M R cubed. Do you remember this formula?
Yes.
Yes.
Now, TB squared is equal, similarly, 4 pi squared G over M divided by RB cubed. They ask for TA by TB. Divide these two equations. If you divide them, you will get TA squared by TB squared equal to 4 pi squared over GM will cancel with 4 pi squared GM. So you will end up by RA cube by RB cube. صحيح شباب؟ But RA is equal to 4RB. So this is equal to 4RB all cubed divided by RB cubed. Let me rearrange it. So this is equal TA على TB all squared equal to 4RB over RB all cubed. RB with RB will go. Since we are looking for TA by TB, so I have to take the square root for both sides. So take the square root here and square root here. So at the end you will have TA over TB, just to eliminate this square, equal to square root of 4 cube, and if you calculate it, you will get the answer 8. Clear يا شباب?
Clear.
But square from where you got it?
Sorry?
T square from where you got it?
This is the equation. If you go to your textbook, the equation is T squared is equal to 4 pi squared over GM. Actually, this is kind of a trick. If you forget this squared, you will get another answer. You will get it 4 cubed. يعني 4 ضرب 4 ضرب 4. ما راح يطلع معك الانسر.
It is in the formula sheet.
I'm not sure what you have in the formula.
Yes, it is in the formula sheet.
Is it in the formula sheet?
Yes, it is.
Yes.
Okay شباب. يعطيكم العافية. We finish all the questions.